Why the hell did the US military spend almost $23 billion and struggled for so long to replace just the M2 Bradley from the early 80s to face peer adversaries like Russia or China? And yet, we haven't seen any working product for almost 3 decades. In large part because the Bradley turned out to be so effective, despite its rocky start, that every replacement had to be significantly better to justify the cost. So the first serious attempt to replace the Bradley dates back to the mid-80s, when the Armored Systems Modernization Program's plan was to create a whole new family of vehicles to dominate the battlefield. They thought about maybe 4 new vehicles with 24 different variants that would replace the M1 Abrams tank, the M109 Paladin howitzer, and the M2 Bradley all at the same time to cut costs and simplify logistics. So it sounds great on the paper, and the Army set out to create an entire fleet of next-generation armored vehicles with the ambition that only unlimited Cold War defense budgets could justify. Basically, it was about an arm race with the Soviets, but the program was hugely ambitious, to the point of being unrealistic, because trying to develop 4 different vehicle families simultaneously with 24 variants meant the engineering challenges and costs spiraled out of control almost immediately. And by the early 90s, the program was burning through hundreds of millions of dollars without producing anything close to a fieldable vehicle. So then in 1992, the ASM program got canceled after the Cold War sorta ended with the Soviet Union falling apart, and suddenly the threat that justified spending billions on new armored vehicles just disappeared overnight. And just like that, the US Congress and Pentagon leadership looked at ASM's ballooning costs and decided the whole thing that was costing taxpayers roughly $800 million wasn't worth it anymore, and there wasn't anything to show for except some prototype components. So then the Army spent the rest of the 90s upgrading existing Bradleys instead of replacing them. But by the early 2000s, yet again, some top brass were convinced they needed something radically different for the future battlefield. And this time, they called it the Future Combat Systems, and it's all about high-tech modernization. And of course, the firepower can't be compromised. So they have to be made in a way that drones and all the advanced battle networks technology can be implemented. In a way, it's like they were trying to build something that an F-35 has, but on an armored IFV. But this was back in 2003, so none of that existed. But the overall FCS concept for an infantry fighting vehicle was all about a fast, 20-ton tracked vehicle packed with sensors and computers. Basically, the fighting doctrine is more about staying stealthy, and also lethal beyond visual range. And that design was designated the XM1206 Infantry Carrier Vehicle. And it was a fairly lightweight IFV designed to carry a full squad while relying on advanced sensors, drones, and active protection systems to detect and engage targets at long range, rather than surviving direct hits with heavy armor. So then, they spent almost 8 years and $18 billion trying to make this vision come to life. But guess what? None of the vehicles could actually survive a battlefield full of RPGs and roadside bombs that were shredding vehicles in Iraq and Afghanistan during the same years FCS was being developed. The Iraq War basically showed that the FCS vehicles proved too fragile for the kind of combat American troops were actually fighting. So after pouring money into the program for nearly a decade, the whole thing collapsed in 2009 without producing a single operational vehicle. Just like small arms that the military were developing. The reason was that the technology also lagged way behind what FCS required back then, and the autonomous capabilities turned out to be far more difficult to develop than anyone expected. So then the Army learned the hard way that the human brain is still far better at navigating a dynamic battlefield conditions than any computer system they could build. So they rushed that technology into service before it was ready. If you look at all the weapon design failures, the FCS was definitely one of. Probably the most infamous case of overambition in defense acquisition, where the Pentagon tried to skip an entire generation of technology development and jump straight to a revolutionary capability that simply wasn't achievable with 2000s-era tech. And all the Army had to show for, after spending $18 billion, were just some test results and some debriefs on what not to design next time. Which is fair for engineering, but it was extremely wasteful. Okay, but this isn't over just yet. While this was just an armored IFV design costing that much money, there were other, even more expensive weapon replacement programs going on at the same time, which there will be other videos going over them on this channel. But this time, the US Army tried a completely different approach in 2010. And for this time, they introduced a new program known as the Ground Combat Vehicle Program, and that was meant to be more focused by simply building a direct Bradley replacement infantry fighting vehicle with maximum protection for troops based on lessons learned from roadside bombs in Iraq and Afghanistan. So the requirements were that it could carry 9 soldiers, it should survive hits from RPGs and IEDs, and still maintain mobility to keep up with Abrams tanks. So then, 2 industry teams led by BAE Systems and General Dynamics started designing these massive vehicles to meet those survivability requirements. The GCV prototypes that emerged were absolute monsters, weighing between 60 and 70 tons, and one of the concepts couldn't even fit on a C-17. And the reason they got so heavy was because the Army demanded protection levels that could withstand basically anything an enemy could throw at the vehicle. On top of that, there are active protection systems to shoot down incoming missiles, and hybrid electric drives that were supposed to improve fuel efficiency despite the enormous weight. But the designs traded mobility and air deployability for protection in a way that created serious operational problems. But they were just too big, and this meant the Army wouldn't be able to rapidly deploy GCV units to global hotspots via air. And the projected unit cost also climbed to more than what an Abrams tank cost. And when some Pentagon officials started calculating what it would take to buy enough GCVs to replace the entire Bradley fleet, the total program comes out to be so astronomical that made Congress extremely nervous. So, with defense budgets tightening around 2013 and criticism mounting from lawmakers and defense analysts who pointed out that the GCV was too heavy and too expensive, the Army canceled the program in 2014. Once again, no new vehicle entered service, and the Bradley replacement effort had now consumed more than $20 billion across multiple failed programs, with absolutely nothing to show for it except some prototype vehicles that never made it past the testing phase. If you pay close attention, you would notice that the pattern kept oscillating between extremes, where FCS was too light and relied on unproven technology, then GCV swung to the opposite extreme by being too heavy and too expensive, and neither approach produced a viable vehicle that could actually replace the Bradley. And by the time each program got canceled, the threat environment had changed again, and it will always change, and whatever requirements were will always be outdated. So by 2018, when you thought the military would at least pause and maybe move on to something else, but the Army was determined to try again. And this time, whether you think it's a new program or rebranded, it's called the Optionally Manned Fighting Vehicle. Still going after the Bradley replacement. And that was part of the broader Next Generation Combat Vehicle initiative, and the name reflected a desire for a high-tech vehicle that could operate with or without a crew on board, using remote controls and possibly some autonomous modes. The vision the Army had was an infantry fighting vehicle with advanced sensors, digital fire control, hybrid electric propulsion, and integrating whatever new technologies as they became available. And after multiple contractors had competed with mature designs that could be rapidly prototyped and tested. However, the first few OMFV concepts that derived from the European CV90 actually stumbled badly because the requirements proved so daunting that most contractors dropped out of the competition. And that includes contractors like BAE, Oshkosh Defense, and SAIC. And why is that? And what were the insane specs that these engineering firms couldn't develop to meet the requirement? So for that, let's look at the actual spec. The Army wanted a vehicle that was lighter than GCV, so it could be transported by air. It had to be more survivable than current Bradleys against modern anti-tank weapons. It had to have new sensors and networking technology, plus a 30 to 50 millimeter massive cannon. And that's not all. It also had to operate in optionally manned modes, and trying to achieve all of that simultaneously within a reasonable budget and timeline was just basically impossible. But 2 companies were able to submit bids on time, and that will be General Dynamics Land Systems Griffin III and the Rheinmetall Lynx KF-41 from Germany. But the German one literally failed to ship to the United States in time for the evaluation because of logistics problems getting the vehicle across the Atlantic. And just for that reason alone, the Army was like, nope. Because there is no competition, the Army was facing a default down select to the only bidder, so they canceled the entire OMFV solicitation. This was now the third failed Bradley replacement effort in less than 2 decades if you don't count the ASM program from the 80s, and defense analysts were openly questioning whether the Army even knew what it wanted anymore. Because the constant requirement changes and program resets drains everyone's resources, and it's a serious institutional problem in the acquisition process. And there was an analysis from 2020 summarized the situation by noting the Army has spent $20 billion to develop a Bradley replacement without a single vehicle to show for it. And the venerable 40-year-old Bradley continued serving as the Army's primary infantry fighting vehicle by default because every attempt to replace it had collapsed. But yet again, the Army tried again. And this time, it's the XM30 Mechanized Infantry Combat Vehicle to signal a totally clean break from past failures. And this time, the people in charge promise to be more realistic about requirements and are more willing to accept an 80% solution using proven technology instead of insisting on revolutionary leaps that might not be achievable. So in between 2020 and 2023, the Army ran a digital design phase where 5 competing contractors were each given roughly $60 million to develop preliminary designs in a virtual environment using computer modeling and digital twins before building any physical prototypes. And this allowed the Army to work closely with engineers to refine any requirements and pinpoint any problems way earlier before committing to making prototypes. So, what exactly can the XM30 do better this time besides carrying up to 6 people plus a 2-person crew into battle? The fire control now comes with an unmanned turret that mounts the XM913 50mm autocannon that can be programmed to shoot airburst rounds, effective against drones or entrenched troops. An operator can remotely control the turret from within the vehicle, which saves internal space and potentially allows a smaller crew compared to the Bradley's 3-person crew. A hybrid diesel-electric propulsion system now provides better fuel efficiency, quieter operation when running on battery power for stealth missions. The hybrid engine also reduces the vehicle's thermal and noise signature, and in a battlefield environment saturated with cheap thermal imaging drones that can spot vehicles from miles away, being able to run silent makes a huge difference for survivability. The Army insists the XM30 to be full digital, with electronics and software that follow an open modular architecture, setting it up for future integration over the vehicle's life without having to rebuild the whole system. For survivability, the XM30 likely include an active protection system to intercept incoming rockets or missiles, plus adding some modular armor packages that can be adjusted based on the threat environment. The Army hasn't specified exact weight limits, but the target is a vehicle in the 40 to 50 ton range that every C-17 can carry too. But requirements on paper are one thing. Actually building the vehicle is where past programs have died. So who's really trying to make the XM30 a reality this time? In mid-2023, the Army selected 2 industry teams to build prototypes for head-to-head evaluation. The first was General Dynamics Land Systems, a big contract to build prototypes of their design based on the Griffin 3 technology demonstrator. And the second contractor was American Rheinmetall Vehicles, partnered with Raytheon, Textron, and L3 Harris to build prototypes based on the KF-41 Lynx that's already in service with Hungary. The General Dynamics Griffin 3 conventional layout design has an unmanned turret with a 50mm cannon, hybrid electric drive, and weighs roughly 40 tons. The main focus for them was reliability over bleeding-edge innovation. But the biggest concern is that it might be too conservative and end up being just an incremental evolution rather than a true next-generation leap forward. The question is whether playing it safe is smart or settling for mediocrity. And Rheinmetall is betting the Army wants something bolder. The American Rheinmetall's KF-41 Lynx can be reconfigured for 2 crew and 6 dismounts to meet Army requirements. And the vehicle is slightly heavier at an estimated 44 tons, with more internal volume for future upgrades. Rheinmetall's advantage is that the vehicle already exists in production form with actual combat units operating it. But the downside is that the Army will demand changes to meet specific U.S. requirements, which could complicate integration and increase costs. So 2 solid contenders: mature technology, realistic requirements. Sounds like the XM30 should be a slam dunk. But we've heard that before. And both prototypes are supposed to be delivered in fiscal year 2026 for extensive testing. And the Army plans to choose a winner by 2027, with low-rate initial production beginning by 2029 and full operational capability in the early 2030s. And that timeline puts the first XM30 units roughly 50 years after the Bradley entered service, but only if we assume nothing goes wrong. But the biggest question is whether the Army can resist the urge to overload the XM30 with extra features and requirements during development, because of the temptation to add every shiny new thing that has previously killed multiple programs before, when costs spiral and schedules slip. The Bradley replacement saga has been a cycle of overreach and compromise for decades. If the Army sticks to the stated plan and resists adding every shiny new feature that comes along, the XM30 might actually make it to production. If General Dynamics or Rheinmetall can deliver prototypes that meet requirements without massive cost overruns, there's a real shot at breaking the curse. And if Congress keeps funding steady and doesn't gut the budget halfway through development, the timeline could hold. But if requirements creep starts adding drone swarms and other next-generation capabilities that aren't matured yet, then the costs will spiral. If either contractor hits major technical problems during testing, the program could stall. If budget cuts force the Army to choose between the XM30 and other priorities, history suggests the new vehicle loses. But until the first production units are rolling out of factories and getting issued to combat brigades, it's too early to call this a done deal.